Hey, Science 20s. Today is part one of the earthquake lesson. Earthquakes are insane, and we in Alberta rarely ever get them. In fact, kind of the only earthquakes that have ever occurred in the last decade or so have been from oil companies fracking the earth and cracking underneath that causes little bits of waves. One of the largest earthquakes in human history occurred actually up in Alaska. There is a massive fault line that runs on the west coast of like where Alaska is, all the way down BC on the west coast. And this fault line is basically two plates are pushing on each other. We'll get to that in a second. But this one was 9.2, and I'll link this. This is a link which I'll have in the lesson plan. You can watch it if you want. But in some places from this earthquake, the ground shifted up or down 8 feet. So I'm a tall guy. I'm 6'2". The roof in the classroom is a little bit more than 8 feet. But just think of what that would do to places. Would buildings fall over? Yeah, absolutely. And then what happened some places is it happened in the middle of the ocean, and it just went and moved the ocean up 8 feet. So all that water rushed inland, and then all of a sudden you had all of these sea animals that were now 8 feet above the ocean. It was crazy. So that's one of the biggest earthquakes ever recorded. And we'll talk next lesson, not today, about how that's calculated. We're just going to talk about the science of what causes an earthquake today and the waves that they do cause. Okay. Earthquakes in a lot of places cause crazy amounts of destruction, and sadly, a lot of human lives are lost. The reason why is that it's the buildings that fall on people. It takes a lot of money and a lot of engineering to make a building earthquake proof. Japan has all of these beautiful skyscrapers that sway with the waves, but in other countries that don't have the infrastructure, they just fall over. I had a link at the start. If you clicked on it, you would have saw some different earthquake videos where buildings are swaying and some buildings just fall down. And that's what unfortunately causes people to get killed. So if we look at Japan had an 8.9 earthquake at this one, and about 16,000 people died. The Haiti earthquake was a lot worse, 9.4, and there's 200,000 people died. So, okay. So very, very dangerous. Okay. Why are earthquakes so dangerous? It's because the energy in an earthquake is so far beyond basically anything humans can do, with the exception of nuclear bombs. That's how much energy there is in an earthquake. You have all of the mass of the earth moving. Okay. Earthquakes are caused by tectonic plates, usually from converging tectonic plates. And you have one plate slipping under the other, and it catches for thousands of years, building up pressure, and then it kind of skips forward a little bit, and that little skip causes an earthquake. So that's the idea. When plates are pushing up against each other, pressure builds. Eventually, this pressure is released, and an earthquake occurs. Now, where the snap occurs forward, or where that break, or where the initial earthquake happens, that's called a fault. And there's fault lines that run everywhere all over the world, where we're just waiting for the next. We know earthquakes will occur because you have the plates converging, and it's only a matter of time until it occurs. The San Andreas Fault, I think, was a movie with The Rock that talks about this big fault line that runs down the United States West Coast, right? There could be an earthquake tomorrow that's 9 on the Richter scale and buries like half of that area. Like it's going to happen, but it may not happen for another 100,000 years or a million years, but the pressure is building. Okay. Now, when that snap occurs forward, or that skipping occurs, all of the energy travels from the fault in all directions, 360 degrees of direction. It travels straight up, and that's called the epicenter. So deep underneath where the tectonic plates are butting up against each other, when the earthquake occurs, or when the fault happens, when the breaking point occurs at the skipping, directly above that is the fault. So if you think of a tectonic plate kind of going down like this, right, and there's still crust on top and something like this, right? So we don't see it as that because this will be kind of flat. If there's a skipping point that occurs, I don't know, like right here, the epicenter is directly above that on the crust. That's where we're affected. Okay. And these waves travel everywhere. They go everywhere. They actually go straight down through the earth and can be felt on the other side of the planet. And they travel hundreds and hundreds of miles. Really bad earthquakes off the coast of BC are felt in BC, and some minor earthquakes in BC. Some people have said they felt them in Western Alberta. The central part of Canada is super, super tectonically dead. Like, that's the Canadian Shield, so they're never going to have earthquakes there, and there's really no oil drilling that's happening, so you can't have artificial earthquakes either. Okay, so let's talk a little bit about waves. Okay, there are 3 types of waves that earthquakes occur, and that's the meaty part of today's lesson. The first waves that occur are called longitudinal waves. Okay, longitudinal waves are also known as P waves or primary. They're the first waves that occur, and they are more like a push. There's no ripple action, it's a push. So to draw a picture of a longitudinal or primary wave, it goes like a shove. And people who have felt them say they feel like a thud, or it feels like, huh, like that you're like an elevator goes down just for a second and then it's gone. Longitudinal waves are super fast. Because they're just going in one direction and not oscillating or moving up and down like a snake. On Monday, I'm going to show you guys a slinky video that I've shot that's going to show what slinkies look like. But these arrive first. And animals have been known to kind of sense the P waves, and that's why they sometimes act bizarre. It's not like they can sense an earthquake is going to occur. They can't do that, but they can feel the P wave maybe before humans can feel the next types of waves. Okay, so longitudinal waves are first, also known as P or primary waves. Okay, the next waves in most medium intense earthquakes do the damage. They're called transverse waves. They're also known as S waves or for sway. And these go like that. They're an oscillating effect, like a ripple, like a wave in the ocean. Okay, the ground roils beneath you, like it feels like you're going up and down, and that causes damage. That's what, if you think of like a pillar, a stone pillar, and the ground is going like that, it will cause the pillar to shift to the side and topple. Transverse waves cause extreme damage. If the buildings aren't built for it, they will fall over if the earthquake is strong enough. Okay. And the last waves in really, really bad earthquakes are called surface waves. Surface waves are very, very slow. So in very bad earthquakes, they will travel far enough from the epicenter to cause damage. These kind of peter out. So medium intense earthquakes sometimes don't have the surface waves. And the surface waves are shaking. So it's traveling like side to side. And in the videos, if you've seen an earthquake where people are like they're going back and forth and everything's like jumping up and down, those are probably the surface waves. They arrive last, and sometimes they arrive maybe 30 seconds or a minute after an earthquake, depending on how slow or how far away the epicenter is. And you may have people thinking the earthquake's over, and they might go to help somebody by building, and then the surface waves causes the rubble to shift, and that's what kills a lot of people, is they think the earthquake's over, and then the surface waves show up. Okay, so let's just review a couple terms. The epicenter is directly above the fault. And the focus is the break or skip at the fault. So if I have so this is like two tectonic plates, and then that's where the plate kind of moves forward a bit. This is the focus. And from here, you'll have push waves that will move out first, then S waves. Well, the S waves are occurring at the same time, but they're just moving slower because they have more, and then the shaking waves go out. Directly on the surface above that, like where a human is standing, that is the epicenter. Okay. And we'll talk about what and how earthquakes are measured on Monday. Today, I'd like you guys just to think about earthquakes and watch those videos. So there's more videos today. So watch a couple of those links, and then I'm making you guys do an earthquake meme and put that in Google Classroom. So that's your homework for today. Please remember that the geology assignment is due by the end of this week, that you would have already have started. So just keep that in mind. Okay, bye guys.